this video, we will discuss about the resources we have. The resources consist in the hardware we have. The hardware can be local I/O or local variable, as well as remote variable if we talk to a remote device. In this video, we will concentrate on local resources. The remote resources will be discussed in the next video. First, let's take a look at the hardware we have. This is the material I use for this training. So it's a T-Box MS. So the T-Box MS stands for modular system. So it's based on module installed on a rack. And we have several sizes of racks. Just take a look to the rack. So here you see one empty slot. So the racks is based on slots. We have different size. We have racks with 3 slots, 5 slots, 10, 15 and 20 slots. So this corresponds to slot 0, slot 1, slot 2 and slot 3. And we can see here the slot 4, which is empty. In terms of modules, I have a power supply module in slot 0. I have the CPU in slot 1. By the way, the CPU, you can insert it either in slot 0 or slot 1. Then you have the simulation card, which allows us to simulate digital input with the buttons, allows to simulate digital outputs with the LEDs, analog inputs with the potentiometer, and analog inputs, and analog outputs with the LEDs here. Then we have the GSM with its antenna. Well, in this case, I just used a right angle antenna, but normally you have an external antenna. Here I have also an LT2. I will probably use also during those videos. If we look at the LEDs, there is one LED very important, which is this LED here next to the button. You see, on the MS CPU here and on the LT2. So it gives the same indication, the running mode of the CPU. And we see 2 different running modes. 2 Hz, like in the LT2, means the program runs normally. Half a Hertz means the program is stopped. So, okay, maybe take a look. Let's take a look to TwinSoft to see why our program is stopped. So if I go to communication RTU identification, I can see effectively that the program is stopped. And why? Because T-Box runs in evaluation mode. Remember, when TwinSoft is not licensed, and you send the program to T-Box, it will stop after 2 hours. If I send the program again now, no issue, I can. The evaluation mode does not prevent from sending a new program. Just the T-Box stopped after 2 hours. But you can develop all the features without any issues on T-Box. If I now take a look to the T-Box itself, I wait it restarts. Okay, it has restarted. So now I can see it flash now at 2 Hz like on the LT2. All the LEDs we have on each module. So on each module you can see you have here CS and error, CS and error, CS and error. It indicates the status of the module. So each module must be declared in the CPU from TwinSoft. So there is no automatical detection of the card. There is an automatical verification that the card is properly installed and corresponds to the declaration it has in TwinSoft, but there is no automatic configuration. So we will have to declare in TwinSoft each card to its position. When the declaration is correct, the LED CS will burn, indicating the card is properly installed in TwinSoft and it corresponds to its position on the rack. So let's start this in TwinSoft now. In TwinSoft, we declare the modules we have on the rack in the folder I/O. So you see we have at the moment one module declared, which is the CPU itself, which is the minimum when we start an application with an MS CPU 32, is that TwinSoft creates already this CPU. Each module has a software address which corresponds to its slot ID in which it is inserted. There is one exception to this. It is the CPU. The CPU can be placed on two slots, slot 0 and slot 1. This is because we support T-Box redundancy, meaning we insert two CPU on the rack, and this will be on slot 0 and slot 1. When we use only one CPU, then we can put the CPU either in slot 0 or in slot 1. In my case, I have put the CPU in slot 1, but its software address is 0. So the first slot available, which is a slot 0, will have, for the card it is inserted to, the software address 1. Then let's add I/O cards. So for this we have this button here, add an I/O cards, and we see all the list of available cards with the identification that we can see on the top of the cards. So the first card I have is a power supply, which is reference AC 30 watt. So I select it and I have to give an address, and as I said before, the first address available, even if it is in slot 0, is 1. The second card on slot 2 is the simulation card. So I will add the simulation card. And in this case, slot ID equals software address. The next card I have is the GSM. So I insert the GSM. It's either 3G, 4G or LTE, so it's the same identification. So I select this model and it is in slot 3. After having declared all our cards, let's see what we have inside the card. So I can open here the directory input outputs, and then we can see inside the cards we have groups, and each group corresponds to a type of channel. Group 0 has all the communication ports of the CPU, so we can configure each port individually. So for serial port, it's changing baud rate, for instance, or it is changing protocol. Those are default protocol available in the firmware, but we have a possibility to add supplementary protocols using add-ons. This will be discussed in another video. Regarding Ethernet, we can select different IP ranges, or we can work in DHCP if you want T-Box to acquire an IP address from a DHCP server. Regarding USB, nothing to configure to communicate with T-Box, but you can configure USB slot, for instance, to have a Wi-Fi stick. Then you will define here the configuration of the Wi-Fi you want to apply to the Wi-Fi. Let's take a look to other groups. So the other groups are divided into digital input, digital output, analog input. In fact, it consists into resources available in the CPU itself that if I need them, I will declare them. For instance, if I go to the digital input group, I see I have two digital input available. One is the stop button. On the front side of the CPU, we have a stop button. This button can be used to do any special action when you press this button. Let's imagine that I want to stop the program when I press this button. So I will declare this resource. So I just double click and I change its name. Okay, and I call it stop button. Maximum 15 characters, no special characters, no space. And I do OK. You see the icon has changed. It means these resources is now available in the list of tags and can be used anywhere on the program. It can be used to generate an alarm, it can be used in the process, it can be used in data logging, in any features of T-Box. I can now use these resources. Digital output, nothing special to do with it. Analog input, for instance, I want to use the internal temperature so that I can trace the temperature inside the T-Box. Then these resources, I will declare it as a tag. So to do this, I just double click, change its name, call it internal temp, and I click OK. If I now go and take a look into my list of tags, I see I have now 2 tags, my stop button and my internal temperature I can use anywhere I want. Let's take a look now to the simulation card. So in the simulation card we have 4 groups. One group with digital input, digital output, analog input, analog outputs. So remember the process we want to control. So a pump with a water tower and valve. So I will define the resources I need for this process. So in the digital input, for instance, I have an input at the door which indicate me when the door is open. So I just call it door. Then I have another input to activate the pump. So I call it start. Then I have another input to stop the pump. Then I call it stop. Then I have one output which corresponds to the pump. I have another input which corresponds to a lamp. Let's imagine that I want to switch on the lamp when the pump is running. And in the analog inputs, I want to measure the pump temperature, and I want to measure the water level in the tower. When I go into the list of tags now, I see all the resources that I have declared, which constitute the tags, which are also known as global tags, meaning they can be used anywhere in the program. Let's take a look to the column value. This column will show you the current value of the tags. Well, at the moment there is nothing to show because we are offline. So first I will go online. So remember, we go to communication, PC setup, and I activate USB and I turn online with USB. Okay, now it displays stars because those tags are not known yet by Twinsoft. In fact, when you open such a list, Twinsoft carries out Modbus communication to the T-Box using those Modbus addresses. And those Modbus addresses, they must be first declared in T-Box so that Twinsoft can receive values from it. So let's send this to T-Box. Send. Okay. Okay, T-Box has restarted. And now we can see value. So my stop button, if I move it, I see the value changes. There is nothing behind, but at least the input is working. This is the internal temperature inside the CPU. Then I have the inputs that I have declared to simulate the door, to simulate the start, to simulate the stop, and the 2 potentiometer to activate, to simulate the pump temperature and the water level. Let's just take a look to those analog inputs. You see they vary in fact from 0 to 100. Well, in fact, each analog input can be scaled to real value. So imagine that my water tower has a minimum level of 2 meters and has a maximum level of 10 meters, and I want to have a resolution of 1 centimeter. So I mean I can scale my input to 2 to 10, and then everywhere in my program I will use those real value. So if I send now this to T-Box, any changing needs to be sent. So now my scaling has been updated, and when I turn the potentiometer, it will change from 10 maximum to minimum 2. Well, it's a little bit less, because potentiometers are not precise potentiometers, but for doing simulation this is far enough. Let's take a look to the GSM card. So the GSM card has one group of communication ports, and we have 2 communication ports. The GSM card has a added RS-232 or RS-485 communication port, and we have on top the GSM itself. Let's take a look to the GSM configuration. Before we go to the configuration, so in the GSM card you need to insert a SIM card. Now if I open the document, we have here an example with an LT2, TG2, but whichever module it is, it's the same principle. You have a small tray and you insert a SIM card, which must be a standard or mini SIM card, and then you insert it in the back of the module. In terms of configuration, nowadays SIM cards are always to be used in IP communication, so you have to check this IP box, and you have to give the APN. So the APN depends on your operator. For instance, for me in Belgium with my SIM card, it's M2M Proximus.be. The pin code, if you have defined a pin code on your SIM card, you will type it here, but I haven't, so I will leave it empty. That's all you have to do in terms of configuration. Now, for each communication port, we provide 2 tabs that allows you to monitor and control this communication port. And for the GSM, it's very important that we can monitor the quality of the GSM, and we can monitor the connection of the GSM. So let's take a look to those tabs. Well, first, those tabs provide resources for whichever model of port it is, whether it's an RS-232, whether it's an Ethernet, whether it's a GSM, the same variables will be available. But of course, some will be useless and some will be required. So let's take a look for the GSM. So I have one variable which will give me the IP address returned by the operator. You don't decide yourself which IP address the GSM will take. It totally depends on the operator. Through this variable, you will know which IP address your T-Box has. So I just double click and I click OK. The signal level, so you know, like on your mobile, you have bars indicating the quality of the signal. The same for the GSM. The modem state, this helps us in case of problem to know at which state the GSM has a problem. A little bit below we have the current network. This variable will return us whether you are connected in 4G, 3G or GPRS, because it's not because your SIM card supports 4G and the GSM supports 4G that you will be connected to a 4G network. It depends on the availability where the T-Box has been installed. And the byte count, useful to measure the volume of data transferred by T-Box to know what amount you would have to pay. This is for analog 1. For digital 1, I will just declare one of them, which is the hook link, which was when we had an analog modem, it indicated us the modem was off hook. But as far as IP communication is concerned, it just indicated we are linked. This tag can be used to inform us we are physically connected to the network by reading 1. By writing to it 0, we can reset the GSM. So that can be useful to, in case of problems, if we lose an IP address, so that we can, in the process, just reset the GSM to restart it properly. So we click OK. We take a look now into our list of resources, and we see supplementary tags associated to COM8, which correspond to the GSM. You can of course change the name here, the name of the tag, as long as there are less than 15 characters, no special characters and no space. You can define any name. So let's send this to T-Box to see the result. Program has now restarted. So let's take a look to those variables. So it can take some time. So I see now the GSM is registering. It's now registered. 26 mean GSM is registered. I will get a signal level. Okay, signal level of 2. Current network 2 means it's a 4G, and I will receive an IP address. Here we are. So an IP address is a 32 bits variable, and TwinSoft allows you to display tags in different format. So I can display such a tag in IP address. So I can see which IP address I have at the moment. 46.178.206.167. Let's talk a little bit about IP addresses. I have taken some note just to discuss about it. So IP addresses, they can be public or private, and then they can be dynamic or fixed. Those are the ranges for private IP addresses. When I look at the IP address I have, it's not in one of these ranges. So it means I have a public IP address. A private IP address cannot be accessed through internet. So my PC is connected to internet. So if I try to communicate to this IP address, if I go to communication PC setup and I select IP, and I select here, I type the IP address corresponding to my T-Box now. I will connect, and you see now I am online with this IP address, so I am connected to my T-Box through internet. And by the way, you can see the byte count is increasing because, okay, I am permanently communicating, I am doing Modbus communication to all those variables. So let's go back to USB. Now, if you realize that you receive from the operator a private IP addresses, it means you will not be able to access T-Box through internet. In such a case, we provide a tool called T-Connect, for which we will have a video explaining how we can use it to access T-Box easily. Then, dynamic or fixed. This IP address I have now, well, in fact, with my account, I have a dynamic IP address. So probably in 1 hour time or 2 hours time, it will be different. So it means I cannot access the T-Box directly with its IP address because it changes all the time. But in such a case, then I can use a DIN DNS service, which is a supplementary service. Using DIN DNS, you do not access Tbox anymore with an IP, but with a name. So the DIN DNS service, you declare it into IP parameters DIN DNS. Here you will declare your DIN DNS account. Once you have created your DIN DNS account, if I go to the GSM configuration, I will go to TCP/IP, Advanced here, and I will select my DIN DNS account. So each time IP address of Tbox will change, it will inform the DIN DNS service and it will refresh the IP address corresponding to the name. That's it for hardware resources. Let's close a little bit this. Now let's take a look to system variables. System variables could be assimilated to communication variables on the way that they provide information on the CPU and on RTU features. Like for communication variables, they are divided into digital and analog. So if I take a look to digital, well, first one, for instance, is named tick second. Okay, it changes each second. So if it's useful, if you do some counting or you want to do something flashing, so let's tag this variable. So I tag it, okay, it becomes available into my list of tags. Other digital variables are, for instance, error on certain services, for instance, error sending email, error sending file, error synchronizing the clock. So those flags will change to 1 if such an error occurs. So, for instance, I talked about DIN DNS. I have one here, which is DIN DNS error. So let's just tag this one. So if there is a DIN DNS error, this tag will change to 1. If I take a look to the analog ones, the first one are the time variables. So I will tag the 3 first, second, minute. So I just double click, and when I do that, double click, okay. You can change the name, but if I keep the name, you see the icon indicates this resources is not available into the list of tags and can be used anywhere in the program. So let's take a look to the tag list now. So for the new variables I have inserted into my list, I have no values because this new Modbus address has not been declared into the Tbox yet. So I have to send the program so that those resources becomes available. Okay, we see now our tick second changing each second. Typically this will be used into the programs, okay, in the process. The DNS error also to generate an alarm if we have a DNS error, for instance, to send an SMS. And the time variable, we will use it in the web form too, to display the time in Tbox through an HTML page. This ends this video about the local resources. Next, as for the first video, a questionnaire for those who would like to be certified, or if you don't want to be certified, of course, you can also answer this questionnaire and send me the answer if you wish. Thank you. The question for this video: make sure you always use the same application in which we add each time new features. So you add the cards according to what you have on your rack. Check which model of power supply you have. For the GSM, you need a SIM card with an account for IP communication. Typically the operator, they call that M2M account. Declare the IOs like in the video, so the CPU, the simulation card and the GSM, and the system variables. Send the program to T-Box. Send the program by mail. Send a picture of list of tags in which we should see the values and the IP address you have received from the GSM.